Hello everyone, we are live once again. Thank you for listening. Thank you for watching the webinar. This webinar we will be talking about the second project. We'll be doing another review of the project. This time I will be focusing on what I had not done on the previous webinar, but this one pretty much will get you uh, a lot better, a lot more of comprehension through the topics that are covered in the second lesson. So I'll be focusing on the using the PIL library, which is not covered on the lessons. After this webinar, you'll have everything you need to know about PIL, about using the images. I actually even have a little demonstration to enhance your comprehension on what you're doing with PIL. And that's it. Let's get started, shall we? We have a lot to cover, so let me just share my screen with you. Just 1 second. And now I'm sharing my screen. So let's get on what we're doing. So basically, what I'm doing a review on the lesson on PyTorch, because that's almost everything that you have to do on the second project is related to PyTorch. So if you do this on the second project, still get your project to do, and you so I don't spoil anything about the second project, and you still got your project, but you got a lot of comprehension, and you can just transfer what you learn on this webinar to your project, and then you'll be fine. So let's do a quick overview on the project. Let's go back from the beginning. I actually did this on the previous webinar, but let's do it again, just real quick. So when you start working with the projects, you do the basics. You load the libraries, which is Torch, and the end you just run. As you can see, I had already run. I already ran this. Let's run it again. Which what I'm doing is I'm loading the data, which is on this folder. As you can see, I'm concatenating this with this, and I'm getting the train folder, and I'm concatenating this with this, and I'm getting the test folder. On your project, you actually have a validation dataset, which means which is another loader you will get to get another of these guys. And for the validation dataset, you do the same transformation that I'm doing here, the same transformation with the tests that you do on the test side, you do on the validation side, because they are pretty much the same thing, except that the validation you use while you're training to make sure that your model is learning, and the test you use after you have trained everything, and you to make sure that your model has learned everything. So moving on, what I'm doing for the train transformation, I already said that, but I'm using randomizing a little bit, randomizing with a little random rotation, random crop, because why I'm doing this, because it is important for when you're training, and only when you're training. That's why I only do the training. You can see I'm not using any random here in the test, because when you're training, you want you want your network to generalize better, so you can classify images that are not very standard. Like imagine, for example, a picture of since we're talking about cats and dogs, a picture of a dog with upside down, and you still want your neural network to understand that that's a dog or a cat that's upside down, and you still classify it correctly. And for your project you're doing flowers, imagine if you only could classify flower if the picture had been taken under a certain light, under a certain angle, something like that, it'd be pretty much useless, because you could only classify your images on a very, very narrow position, so you miss a lot of classifications. That's not good. That's why you use randomization. Not that the network wouldn't be able to randomize if you didn't use this, but this make sure it will randomize better. So it's always good to have some randomization on the training, and that's what I'm doing here. And with this code, Spirit Standard, you actually go through this on your lesson. So let's not dwell too much on that. This is done, and I have loaded, and now I'm loading a model from PyTorch models. Actually, a pre-made network that has been found to be really helpful. So you load one, you can load the DenseNet. There's a DenseNet here, but I'm actually using the VGG16 since most people are using the VGG16 to train to implement the second project. They actually recommend you to start with the VGG16, but you can actually try the DenseNet. There's more models than these two. There's GoogleNet, if I'm not mistaken. You just search PyTorch models, and you get on Google. You get the documentation with all the models. You actually have papers regarding those models, where you have the researchers explaining how they get to the model, how the model is performing, and so on. I do recommend you to check those papers and check the documentation if you have time. But pretty much that's it. I'm loading the model, and I have to inspect the model. How I go out. This is the part I want to change. I want to use everything here the same way because it has already been trained on the ImageNet, which is a huge data set composed of more than 1 million pictures of several items. So this is already trained. I don't have to train this anymore. What this part does, this features does, it extract the features from the images. So this one is already trained to extract features from images. So it will extract features from cats and dogs as well, and from flowers and plants. So you don't have to train this again. You don't want to train this again because this already has been trained. People spend a lot of time and resources training this. And after the feature extraction, you have to run through a classifier. This guy you want to change because this is trained on the to do the classification on the on the ImageNet. We're not not using the ImageNet because it'd be too big. We're using a smaller data set, like the flowers is a smaller data set. So you wanna tune just the classifier to your data set. This is what I'm doing here. First, this line is gonna stop from training everything, even this classifier. But I have to change classifier. So what we do, we will replace the classifier for us that will model for us, and this output here is -2 because I only have two classes. I have cats and dogs, but you have actually 102 if I'm not mistaken. This is written on your second project, so you can look how many. But this is the output layer of 2 for me, maybe 102 for you. You look how many classes do you have, how many types of flowers do you have. And now what I'm doing here is I'm replacing this classifier. So this classifier was not possible to train because we set requires grad to false, and that does actually freezes the parameters. It doesn't allow for training. But this one I can, and I'm replacing it. And when I do the training, I'm gonna train this classifier, which will replace this one. And I'm not going to train this because, as I already said, this has been training on extraction features from the ImageNet, and that's as good as it gets. You don't have to train this. You're actually not supposed to train this. So this is important to parallelize everything and then replace with this one, and this one will be trained because I have not parallelized for this one. I have parallelized for this one, but this one has been replaced by this one on this line here. So pretty much that's it. So now we're gonna use, as I said before, you're gonna use CUDA for training because you use GPUs, and GPUs is a pretty nice way of training because they allow for parallelization. They speed up the process. They are much faster. And as I said before, this is what our GPU looks like. And you're gonna see by this price tag, which is not, see, this is not even the fastest one, but this one costs $750. That's why Udacity actually provides you with time. Here you have time on the GPU workspaces, but GPUs is expensive, so you have a limited time. You have 60 hours, and I've used it a little over six and 23 minutes to train I actually train a lot of models. I trained that a single time. It's actually going to take you about 1 hour to train a model the first time. And this is the function that I did last webinar for training. It's pretty much what you do on class, but I'm implementing it for a function because it is much better to do this, because on the next part, you're actually going to break this code apart on two files, two .py files, and one for training and one for for classification. So what you're going to do is pretty much take apart these functions and set them on each file that it belongs to. So what I'm actually going to do, as I did do in the past webinar, is I'm going to move this, and I'm going to instantiate the check for accuracy first, and then I'm going to instantiate the function for actually training. Why am I doing this? Because on your project, you're actually going to have to run validation. Validation only means that you're going to do the classification on a data set. So it's much faster if you just, by the end of each epoch, here you have the epochs run through this, and you can see that these guys align with these guys. So after this goes one time, it will be one epoch. Maybe you run for 5 or 6 epochs. I do recommend you to run to 4 or 5. You don't need to do more than that to get above 70% of accuracy. Get 78% of accuracy. It'd be pretty easy to do that. So after each epoch, you do the check on the validation set, which is this is going to be where you're going to pass the validation loader. You're going to check, and it's going to run the prediction and tell you your accuracy has a percentage. So that's pretty cool. So that's why you instantiate the check for accuracy first, because you're actually going to use this function. Much useful if you use this function for validation. Then to actually do a loop for validation here, it's gonna be complicated. You don't have to do this. So after you instantiate these two functions, one for training, one for checking for accuracy, you can actually instantiate these guys, which is the criterion for uh, for optimization in the optimizer. And here I can actually run this code. I'm sorry. Yes. My model is not defined. I did not run this code because I don't have to run this code. I have already trained and saved the model. So I'm not going to do that because it's not really helpful for us right now. We actually are running short on time. So I'll make sure it goes straight to the point. So you run this code and you get the optimizer, and then you run and do the training. And here's what is done. I actually did for 6 epochs, not 2. I have just changed because something, but don't worry. You actually 6 or 5, 6, whatever. I believe 6 is enough. 6 is enough epochs for training, for getting above above 70%. So you can do for 6, even because you don't waste too much time, because your time on GPU is precious. So after you do that, you did the training. Actually, you have to enable the GPU workspace. When you enable, so you can run faster. So you can train faster. Enable, do the training, and don't disable after the training. You want to check for accuracy first, and send your model to CPU. And after sending your model to CPU, you save your model on your checkpoint. Why am I telling you to send your model to CPU first? Because if you don't send your model to CPU, it's gonna save a GPU model, and you can only load the GPU model if you are on GPU mode. So you're gonna actually need to be on GPU to load the model. If you send it to CPU first and then you save it, you can load it whether you're using on CPU or GPU. And if you wanna send it to GPU again, just do model.to. Let me look again if that's model2 CUDA. That's right. Model2 lower cases. Model2 CUDA and send it to GPU again. So you get flexibility if you save your model on CPU. If you don't save your model, don't change your model to CPU before saving it, you're actually gonna change to GPU every time you need to load. So don't do that. Send to CPU first and then you save. So what else? Just saving my model. I'm saving the model itself. I'm saving the state dict for the model. It is important to save the state dict because it is the optimization we did. This is the model. This is the optimization you did after the training. So you need to save both. And actually, we're gonna have to do this on class YGX. It is on your project telling you to do this. You get from it from the folder, and I'm getting from the training data folder. It's the training data that we are using here. The training data folder contains this guide. This is actually a dictionary. I'm attaching it to my model, and then I'm saving my model. So I can you actually make it easy for inference on the next part of the project. So this is how you save your model, which is again is on the PyTorch lesson, but I'm teaching again, make sure everybody understands that. And it will create this file. My checkpoint, actually I spell checkpoint, but there's not a problem saving the model to this file. And then I can load my model after maybe I decide to give it a time and go back to my model tomorrow. You'll be saved, and I can just load it from using this. This is how you load the checkpoint. And after you load the checkpoint, you can load the model from the accessing a key, the same way you do on a dictionary. This is basically a dictionary. So this one loads the model. You see, I have loaded the model. And I'm gonna not do this because I'm not on CUDA. But if I wanted to check for accuracy, which is a lot of classifications, but I'm not gonna do this. So this is pretty much what we went so far. We're back then. I actually already checked for accuracy here, so I don't need to do this. As you can see, I got a 98.6 accuracy on my cats and dogs. We're gonna get less than this for your project, because your project you are classifying plants and not cats and dogs. So running a classification for cats and dogs is much easier than for plants. So that's why I get 98.6, which is awesome. But you may get something like 78%, 75%, above 70%, which is recommended for the project. It's going to be fine. So this is where we were. So in the next thing you're going to have to do is going to have to use PIL, which is the Python library for dealing with images. and it's not covered in the lessons. That's what I want to focus in this webinar, because it is complex to understand what the PIL is doing, and how you're gonna get the how you're gonna run the. Let me go to the project. I'm gonna show you, because it's not in the last one, and I wanna make sure people better understand, so you don't have to. So you don't have any problem implementing this. It's not on the lesson. This PIL part is not on the lesson. You'd also expect you to find somewhere, but I realize it's quite complex. They don't actually give you a great explanation of to do this. That's why I'm actually going to show you how to use the PIL. Give you time for loading. Yeah, this workspace takes a while for loading. Let's check out this beautiful graphic cards. Mm. So this is what you have for the first project. I cannot show you much on this. This is pretty much what we did so far. We save and load the model. So on this part, when you're gonna have to work with PIL. So you have this, you have to define a function. I'm actually gonna work offline right now. I'm just sending moving to my own machine, so I can show you better what's happening. So we're gonna use NumPy, and we're gonna use, of course, PIL, because and we're gonna use matplotlib, because this so what do you get here? You have to define one function, define a function, this function that processes an image, and after you process that image, you're gonna pass an image, a location of an image has a string has a location of your hard drive, something like that, and it's gonna process an image, and the results of this processing is gonna be. So to check if you did everything correct implementing here, you're gonna use this function. What this function does, it is undo we will undo what this function does. So you're gonna use it for testing on, an image. This function will undo what you did here, and if you did everything correctly, this function will show you the original image. Just so do the transformation here, undo the transformation here. If everything is correctly, this will undo the transformation, and everything will be fine. So so let's get going. So I just copy this function so we can check with if the function, this function that we're about to implement is gonna actually work. So let's add another line and actually copy the head of the other function. And let's start implementing. So don't forget to add pil to your import statement because you're actually gonna use this library. You can actually use this or can even put it here, no problem. But it's a good practice to put all the import statements up on the top. So what you're gonna want to do is gonna add import pil here, import pil here. Just this import, add this import here after when you get to the section. It's a good practice. So just don't add here. Mine is a very low, but so what you're gonna do? This image is actually gonna be a string. So let me show you what my environment. I'm actually working from this folder here. So I have an image and I want to load that image. I'm just gonna copy this location, copy the name of this file. Since I'm working on this file, which is on the same folder, I don't have to pass in another folder like we have here. We have to pass this name of the folder because it is working in another folder. So where are we? We are working here. So I want to make sure I'm so this location profile. What we wanna do first, we wanna load the image using pil. That's how you open an image on pil. It's gonna check this string and open the image. After you get the image, it tells you to resize. A good way to resize would be for the thumbnail. Actually use the thumbnail because the thumbnail keeps the proportions. You don't have to do anything to keep the proportions. If you use resize, you're gonna run into a lot of code to keep the proportions. So please use the thumbnail. Get a lot. Will be much easier for you to. And you can do some anti-aliasing, which is also available on the to make sure everything is still smooth after we resize and after we create thumbnail of 25 by 25. It's thumbnail of 25 on the x-axis and 225 also on the y-axis. So 200 an image of 225 by 225. And after that, we're gonna crop in the middle. So how do we figure out what the middle is? Unfortunately, pil has no attribute to just cut in the middle. So we have to figure out where the middle is and cut it there. So we actually have this two attributes we can get. We can get the width and the height of the image using this. Sorry. You don't want to do this. Never do this because this method it does not return anything. Just alter the current image. So never do this. If you do this, you get an error. So don't use this. You just do this, and you will change the image to a thumbnail of 225 by 225, and you're good to go. So uh, Now we have the width and the height of the image. We wanna figure out what to cut it. We're gonna figure out the left, be the width plus the size of the final size of the image. What is the final size that we use for training? The the size of the image we use for training is 224. Since you actually saw this on your project, that's fine. So we wanna figure out what to start cutting the left side and on the top of the image also. Let's call this image size. Divided by 2. And where to end the cutting? Actually, you can copy this. This is where we are going to end the cutting. Don't forget to change to plus here. So this guy is going to figure out where the middle of our image is, what the center of the image is. And now we want to crop it. We actually have a function for cropping. This is going to crop the image at the center that we calculated. What we're doing here is we are calculating. Once again, don't forget this plus symbol, and this minus symbol on the first thing. The first elements shall have the minus symbol, and the other elements shall have the plus symbol. So don't forget this. And now what we wanna do? We wanna start using NumPy. So we're gonna pass that image to an NP array. This guy is gonna become this guy as an NP array. And we wanna divide by 255. Why do we wanna divide by 255? Well, because of functions. The PyTorch and this function both take an image from that is from 0 to 1. And if you look at the image, the way Pew represents the image, the colors is gonna represent from 0 to 225. So what we're doing, we're scaling it back to numbers between 0 and 1. So if a certain color, imagine if the blue color for a certain pixel is 255, when we divide by 255, it's going to be 1. If it is half of that, it's going to be half, it's going to be 0.5. So what we're doing is scaling. Don't forget to scale the image. This is actually on the project. We actually have to do what it tells us to do. It tells us what the means are. These are the means. I'm actually going to copy these links. These are the same links. So I'm just going to copy and paste it. This is the same thing. I have the links and I have the standard, and it tells me what to do. I have to subtract the links and divide it by the standard deviation, because in here it does the opposite operation, and it can show the image. So this is what it does. This is actually written on the project, so it's just following direct instructions. And what you're gonna return, you're gonna actually transpose this image. Why are we transposing the image on this order? We are transposing it because as it is written on the project, you should read this project. Truly make sure to read this project. This is why it's transposing, because PyTorch expects to have the color on the first dimension, and for Peel is actually the third dimension. So what we're doing is we're taking the normal images here. So first dimension, second dimension, third dimension. We're actually just moving this guy everybody keeping the headstone position. So this is what we're doing. We actually changing the color from the third to the first. Actually, I'm going to do some demonstration for you, so you guys can comprehend exactly what I'm doing. By this time, your function is ready. So let me just stop compacting. So imagine that this guy is an image. It's a 3x3 image, actually. So if it is a color image, it actually has 3 layers. So one layer, the red layer, the green layer, and the blue layer. Each one of these carries the information about the amount of this of each pigment. So imagine if you have this pixel was to be completely blue. So this information will be 225 0 0. So imagine if you have no green and no red, just blue, and the maximum of blue. But this is what an image is. It's actually a cube. The image is actually a cube, because what you have is you have layers of colors on your third dimension, and you have the first dimension with the x-axis and the y-axis, and on the third dimension you have the colors. So what does the difference for the images we're using on our projects, that our images is 225 by 225. So we have 225 on the x-axis, 224. I'm sorry, is 224 on the x-axis, 224 on the y-axis, and 3 layers of colors: red, green, and blue. So what PyTorch, well, PyTorch doesn't want you to feed the image like this. It doesn't want this to be the first dimension, this the second dimension. It expects this to be the second dimension, the first dimension it sees. So what we're doing, we're actually just twisting the image. So we feed the PyTorch this dimension first, this colors first, and if I could actually show you on our image, this cube would have 224 on height, so 224 on height and 224 on depth, because we just changed the position of the dimensions. This was the first dimension, the x dimension. This was the second dimension, and this is the third dimension of color. The depth of the image would be the color. Actually, would be 3 layers of color changes, which means 3 layers of colors: the color red, the green, and the blue. And what you're doing, you're just doing this. Just here, check the image like this, and this is what PyTorch expects. You see the color channel has the first dimension it sees, and instead of just sending it here. So Peel loads the image like this, but PyTorch expects the image like this. So this is what we're doing on this code. So now that I have this demonstration, let's go back to sharing the screen. So once again, I'm sharing the screen. So this is what I'm doing. I'm just sending the third dimension to the first position and keeping the relation between the x dimension to the y dimension the same thing. I have to change that. Just the color dimension that has to become the first dimension. So now we have built a function. Let's actually get an output. I'm sorry. I just sorry. I just a typo. Nothing to be worried about. So now you have load the image and did the transformation. And if you did everything correctly, if you run this function on x, which is the output there here, you're gonna see an image. Did I not run? Ah, I did not run this code. Of course, it's not gonna show you anything. And perfect. We did the transformation and we have validation, and this was the hardest on this project, I think. So now you know how to use Peel. This is the function you want to build. This is pretty much the function you want to build. So the Peel part is over. So now it's just to keep doing the project. It's not very difficult right now. Just all you have to do now is actually even erasing my code so I can show you. I'm sorry, this is not what I'm supposed to be. What you're gonna do, you're gonna do this project function, and you're gonna implement something using this, using matplotlib. You're gonna use you're gonna show the image and use the image show to to, the, to display the image and do the plot, the graph with the probabilities, and it's pretty much okay now. This is the rest of this code is on the lessons. So if you actually have problem, I don't believe we have time right now. I just wanted to show you how to use Peel. And I have shown you how to use Peel. This is the function I want to do. And, and I believe that's it for this webinar. sorry, some disconnect. I'm gonna finish the transmission now. I believe everything's correct, and hopefully you can keep implementing projects. Thanks so much for watching, and bye bye.